So next topic which I would like to cover is how do you fix supply chain vulnerabilities and have better security, especially in open source code. I think we have already discussed about SBOM quite a bit in earlier sessions, but I'll be covering that topic again, although in a different context. So let's get started. So open source security is an attack from all sides. As we know, almost all of our tools do use open source in the backend. There can be dependency vulnerabilities, as we discussed just before this session. We use a lot of third-party packages with known CVEs. Even these packages are using other packages, so there are many transitive risks which are associated with it. There are many secrets, as we already saw, that which can get leaked. API keys, tokens in Git history, and whatnot. They can be found in both public as well as private repositories. As we discussed earlier, again, like AI-generated code can be pretty insecure. I think I would like to point about one thing is that because AI-generated code optimizes on the number of tokens outputted, so it doesn't really need to focus on secure code. It tries to spit out code which is fast and which utilizes as few lines as possible. So the code generated by AI need not be more secure, as I think most of the practitioners in this room would understand. Supply chain attacks. This is something which is the core crux of my presentation now. We can see that a lot of times our CI/CD, continuous integration, continuous development pipelines can get affected. They can get compromised. This is an example which I really love, which is called malicious package uploads. How many people in this room know what is typo squatting? Good enough number, I would say 35%. For the rest, 65%, I would say typo squatting is a very interesting technique where attackers upload packages which are very similar to the well-known packages. For example, if you're working with Express.js in NPM, I might be having something like Expressy.js, or I might be making some minor tweaks so that you will feel, okay, it is associated with the official Express.js, but it is not. Many times it contains malware. Thankfully, NPM has worked a lot to remove such packages, but still a lot of scope exists for attackers to upload such malicious packages. This can be very easy if you are working in complex software, given from a supply chain point of view. So the more we automate, the more we need to secure what we depend on. So there are some real-world incidents which I would like to cover to remind us of the risks which are associated. The first example is DeepSeek. In case you were present in my first presentation, I covered the topic where about 400 terabytes of data was analyzed and 12,000 active secrets were found, and some were used many times. Second example is, again, I really like it because of the way how stupid it is. So Rabbit R1 was a device which was sold a lot, and it was basically a plug-and-play device. You can plug it on and you can talk to it. It basically was a ChatGPT wrapper. The great thing that the developers did was they hard-coded their API keys over there. So as a security researcher, if you try to go through the request, not only you can see your conversations, you can see the conversations anybody had with the device. I'm still surprised how the company is still it's not dead yet. So it was a very unique example, I would say, where people really messed up a lot. Another one, because we are in Japan, so Japan Space Agency has been compromised in the past. Actually, in 2016, there was a major state actor attack which happened on Space Agency, after which in 2018, the Japan government also mentioned that we need to be more stringent on the the vendors that we use. In this case and the others, there was an AD, Active Directory server, which was compromised, and it led to a lot of problem. But given the fact it's just Japan Space Agency, so a lot of state actors are behind it. Next one is more recent. This one is actually from last year / this year. Now code coverage is a tool which many companies use to identify how much of my code is covered as part of a merge. So when we merge a code, we want to see how much percentage of our code is covered as part of the test. So anybody who is using this tool basically will include CodeCov into their CI/CD pipeline. So if you affect the tool which is part of the CI/CD, you basically can affect all of their clients. And this is exactly what happened. So in this case, the attackers were able to access a insecure file on the internet. And from that insecure file, they were able to find not the access token for a public storage account. Now this storage account contained the bash uploader script, which was to be used by all of their clients. So they replaced the original bash uploader script with a malicious one. And when the clients used this bash uploader script, they were basically compromised. HashiCorp, Twilio, these are the major companies that were compromised as part of this attack. So supply chain is very important to be secured. Security gaps are baked into the development process. As we know, humans are the ones who have written most of the code. Now, in the future, maybe AI will be, but the errors and the problems will still remain. Developers commit secret or they commit insecure code practices. As we discussed earlier, git ignore omissions are very common as much as we don't want them to be. Too many dependencies. Sometimes we have dependencies into our code which we don't need in the future versions, but they don't get cleaned out. And as a result, we often use many packages indirectly or directly. Please also generate, as vibe coding is becoming more and more popular. There are so many developers who are coming into play without actually understanding how coding works. So there's a lot of blind trust present in the system. All of these tools, in many cases, are generating code which is insecure. As I said earlier, they're trying to optimize on the number of tokens generated and need not be generating the most secure code as we would like it to be. DevOps hygiene, of course, can be improved. Like, people don't really care how to improve or protect their CI/CD because supply chain is somewhat of an ignored concept in my understanding. Maybe I'm wrong. I'm seeing many practitioners here which are interested in SBOM, so maybe I'm wrong. So open source tools that can defend your pipeline. Now, these are some of my guidelines/recommendations which you can use. The first being Gitleaks. So Gitleaks, as I mentioned, will look for hard-coded secrets. Trufflehog will do the same thing. If you're looking at SBOM, there are some tools which you can use, like Trivy, Grype, or Sift. I will cover these tools in a future slide. So all of these tools are open source. You can basically plug and play them into your CI/CD pipeline. They're all open source, as I mentioned, so pretty much free to use. The next one is SBOM. I think we covered this decently bit. So SBOM stands for Software Bill of Materials. If you're working with the US, there's actually an executive order 14028, which mandates SBOM requirement for all federal employment, for all federal government projects, tooling. I think there was a question in an earlier session today, does Japan has a mandate for SBOM, like executive order in the US? The answer was no, but in the US, it is 14028. Why it matters? So we should know what we are shipping, just like we talked about software composition analysis a few minutes ago. We should know what our tools are using in the backend. It will also help us accelerate our incident response. If we know that one of our vendors or their packages are compromised, we can actually look into the process on how we can get rid of it or what backups can we use so as to mitigate that problem. So if we don't know what we are using, we are essentially blind when we are developing a code. It's also useful for compliance and risk management. If your company gets affected and you did not have an SBOM, it will create a bad picture in front of the auditors or the compliance people that you'll be dealing with. So how do you build and manage an SBOM? So I'll be covering two topics here, code as well as containers. So let us cover, I think we have discussed Cyclone DX in one of our previous discussions. These are the three tools which I would recommend. Sift and Trivy are the best. GitHub does a good job, albeit from my understanding, it's mostly for code. So please automatically, so for example, if you have a major release version rolling out, or even if you are having a popular open source project, once a commit gets merged, please automatically generate an SBOM. You can tie that SBOM to that commit or to that version release. So you know that for this version, we were using these dependencies, and for this version, we were using these. It helps in easy management in the future. Attach them to releases, as I mentioned. These can be used in your audits. It also helps paint a good picture for your open source project out in the public. Please update them regularly. Now this one is code SBOM as well as container SBOM. So code SBOM, as I mentioned, for example, by GitHub, it identifies your application dependencies. So your packages might be using other packages and so on. So that can be done via code SBOM. As I said, the tools are the same. You can use Sift or Trivy. A major and somewhat ignored problem is that in container SBOM, where you will be using OS packages, libraries. For example, I might be building my container image with Ubuntu rather than Alpine version of Linux. So image SBOM should also be considered. I think many organizations do not consider it. So app dependencies are not exactly the same as full container contents. Vulnerabilities often hide in base layers, as I gave the example of Ubuntu being the base image. Best practices, whenever you're working with code, please create an SBOM whenever you have a major version release or you're committing into the main branch. For containers, whenever you build a Docker image, please generate an SBOM and upload the artifacts wherever you want to store them. But I think it's a good practice to store it somewhere. So how GitHub helps you manage SBOMs? My presentation is around open source and mostly around GitHub. So these SBOMs can be automatically generated. As we discussed earlier, they use dependency graph. It supports many supported ecosystems. I think in a previous talk also we did cover this ecosystem support from GitLab, although this is for GitHub. Please use the GitHub action. You can upload SBOM. This one is actually not coming. Sorry, my bad. This one is actually not coming from GitHub, but from a related package. But I have seen that this SBOM action does work pretty well. Where to find it? Please go to your repository, code, dependencies, dependency graph. Next, AI can write code, but need not always be secure. I think we have covered this topic multiple times, so I'll just go through it. The credentials can be hard-coded. Many times, input validation is not there because the code has to be working, need not be the most secure one. Sometimes AI does generate packages which are out of date. As we know, internet is continuously being crawled by AI agents. Sometimes they work with older versions, sometimes they work with newer versions. So the recommendations might be to use a package which has known vulnerabilities. It's a bit of risk. Why it happens? As we mentioned, they keep on scouring the internet. And another thing is that they also don't have any context of your production code. For example, AI might be knowing whatever is present in your repository, but it might not know how this repository interacts with other repositories or other software tools. Now, as we are moving more and more towards agents and MCPs, this is becoming better and better. But still, the AI doesn't really need to know except what is present in your open source repository. It prioritizes working code over secure code. Next one is a risk flow. Now, this is where I will present some of the potential, like via a diagram, where you can see the problems can happen into your supply chain. So real attack paths can be infected packages, as we discussed, compromised CI/CD tokens, maybe present as secrets into your code base and maybe not even your code base, but present on the internet. Tampered artifacts, if your CI/CD pipeline is compromised, your artifacts will also get compromised and then they will be used by other people and this propagates to more and more problems downstream. Sometimes people can go rogue. I can say rogue or stupid, but sometimes people do malicious things either knowingly or unknowingly, so it can also happen. Especially with open source where we don't know who people are. Sometimes people who are behind state actors, they also pretend to be genuine developers. It has to be very careful. You have to be very careful when working with open source code. Some of the famous examples I would like to cover is SolarWinds. I think everybody in this room might be aware. May I have a quick show of hands of who knows SolarWinds? About 50%, good chunk. It's one of the most well-known supply chain attacks which happened for the US government, where the vendor was compromised. In Japan, also there have been cases, as I mentioned, for JAXA and whatnot. Another one is a typo squatting example. Like, as I mentioned, Node is a very common place where attackers try to publish random packages which look official, but they are not. They are often having malware inside it. So typo squatting is pretty common. I will cover an example where I found a typo squatting error, not a package, in the later slides, but it was interesting to discover that. DigiNotar, how many people know DigiNotar? I think maybe some of the older folks might be knowing it. Almost 5%. So DigiNotar was basically a certificate authority in the Netherlands. They were compromised in 2011, so their certificates were compromised. And as a result, developers could use their certificate, and for a random user, it will look like it's a legitimate website, but actually it was compromised. It was a random website which looks similar to authentic one. So a famous example was that of Gmail, where people thought that they were interacting with Gmail, but they were working with a compromised website from an attacker, but it looked genuine because of the DigiNotar certificate. It was again a supply chain attack where people did not even know that they were affected because the vendor who was providing the certificate authority was affected. So this is my recommendation. Like, please try to ensure that your CI/CD pipeline is secure. If that gets compromised, these effects can not only be limited to you, but also to your clients and their clients and whatnot. So know before you're exploited. Please track your vulnerabilities in real time. Just having an SBOM is not going to help you. as long as you match your SBOM with an inventory of what is happening in the world. For example, there are tools like WorldDB and Vulners. I like WorldDB because it's available in multiple languages, including Japanese. Vulners is another tool which I recommend. It's basically an aggregator of different open source advisories. So if you have SBOM, you are using, say, Express.js version 3.1, 3.11.1. You can basically tie it that, okay, I will be looking if any new advisories come for Express, especially for this version. Everything can be done via API. So if any new event happens, your security team will know that Express, which is part of our SBOM, has been compromised. Does it affect us or not? That's a different question. But you have to map your SBOM with real problems which are happening in the internet. So how to use these tools? Please subscribe to the vendors and the products. You can integrate them if you want to make it completely automated. You can have an event listener looking for new updates as they are happening. Please prioritize patching based on severity. As security people, we would like to say, please fix everything right now, but it need not comply with the business requirements. So prioritization has to be done, but it's important to manage SBOMs along with risks, vulnerabilities that are happening on the internet. So as we wrap up, my practical takeaways are scan everything. You can use Gitleaks and Trufflehog for secrets. Use push protection from GitHub or GitLab. Use Trivy or Grype for your SBOM. Please build and maintain your SBOM. Maintain them every build or per every merge. Please store them as GitHub artifacts, or you can basically store them on the open container as well. Please harden your DevOps process. I think that's what we have discussed multiple times. Please rotate your secrets when you can, and you should. Please do not use tokens which are forever lasting. I recommend using OIDC over personal access tokens. These are short access tokens which come into play when some action is happening. This is a new technology in my understanding, but I recommend that you do not have secrets. You do not have secrets which have wide permissions or which are lasting for a long amount of time. Next is please monitor for external risk. Just having an SBOM is not going to help you. Please subscribe to vendor alerts. Please subscribe to the alerts which are affecting you, plus for the alerts which might affect you. For example, you might say we don't use Kubernetes, but still keep an eye open if something major happens. Maybe your vendors are using Kubernetes, but just maintain some sort of visibility over major problems which can happen. Please do not trust blindly the AI code. I think we have covered this multiple times. Please treat the AI code as if you were treating a human pull request. And now this one is more of a personal example for me. I have been decently active in open source. Some of my code has been merged into some good repositories, which I think. So if you're trying to contribute to open source and you're a security practitioner, I think most people will know this already. But please do not contribute a security issue as an issue on GitHub. If the repository has a security policy, please follow that. If it's a bug and not a security vulnerability, please create an issue and deal with it accordingly. Now, this is something which I'm proud of. So when I was working with Kubernetes, I found a typo squatting example. So if you look into it, this one is MATHC rather than MATCH. So when somebody was reviewing the pull request, they thought that it looks good, match, but it wasn't. As a result, so this was part of a version of Kubernetes. And they thought the latest version was uploaded, but actually it was not because this part failed. They did not have any errors coming. This is an example of typo squatting, but it's mostly done by error. Our eyes switch between C and H because they are somewhat similar. Next one is again one of the pull requests which I'm happy is it's for a project called Mermaid.js. Some people might have used it for graphing. So they had a bunch of security issues which I patched. And that concludes my presentation. Thank you all.
Thank you, Arpit. Anyone have questions?
So very interesting talk. One thing I want to push back on, and I'm very aware now, and it's very appropriate, I'm wearing an In Toto shirt right now, but I think I would push back a little that inside of the build and earlier parts of the process that the right tool to capture that information is an SBOM. Mm-hmm. Wouldn't an in toto attestation, salsa attestation, things like that be better? Because those are automatically cryptographically verifiable. They're built for security. They're whereas SBOMs tend to be more human readable sort of artifacts that are more generated for humans to look at after the fact and figure out who to blame when something goes wrong. Isn't it better to have like that ability to do that check, that security check that attestations give instead?
I will answer that question in two parts. The first part being, I do not know what you mean by the alternative to SBOM, so I do not know the reference to it. And because of that, I wonder if multiple tools that an organization or a project might use, do they have this kind of, like the validation as you are saying? That is one. Secondly, not everybody in the business context is as technical. So I think SBOMs is still a good to have because it helps humans understand my supply chain risk. But if we are talking about a completely pure tech organization, it might work for the use case. I'm not exactly sure, and I don't know if I can answer your question better in that sense.
Yeah, I'll just say in response that in-total attestations are very widely deployed. There's GitHub automatically generates them in a bunch of cases, as do lots and lots of other organizations. So from a tooling standpoint, they're, I think, more widely used in that part of the process, the build process, and other places than anything else. And it's, I think an analogy to think about here is, do you want something that says that Microsoft said this was okay and is like a written signature by whoever the latest CEO or the security officer of Microsoft is? Or do you want a cryptographic signature that's checked by your tooling?
I would say latter option.
If you want the latter, then I think attestations are the better approach.
I need to study it up, actually.
So.
Thank you for that. Some homework. Thank you.
Thank you for the presentation. And our challenge currently is, how can I say? Sometimes SBOM is a snapshot we ship the software.
Correct.
But vulnerability is sometimes found after the shipping the software. So it is a little bit difficult to matching what component is vulnerable after the receiving or shipping the software. In such situation, are there any best practices, or how can all of you solve these situations?
If I were to solve this problem, so as I mentioned that we have an SBOM associated per version. So I would know that, okay, I'm deploying this version of my product and it uses these 10 libraries and these versions. So I can have a scanner which can like query these databases, as I mentioned, WorldDB vulners, to see if, say for example, this package, say Express 3.10, does it have any new vulnerabilities which is affected? Or if there's any new vulnerability affected for Express, from which version numbers is it affected? Is it 3.10 and before or after? I think maybe having a simple check, maybe in an automated way per day, will help us know if we are impacted based on our SBOM. That is how I will solve this problem. There might be better ways to do it, but it's a very brute force that I'm thinking of doing so.
Thank you very much.
Okay, thank you, Arpit.
Thank you. Thank you all.